So last time we were doing specific heat capacity and we discussed different types of questions based on it. Now here, this is the list of the specific heat capacities of some important compounds. Water has the highest specific heat capacity. So if I give you substance A, substance B, substance A has a specific heat capacity of, let's say, 0.1. Check the units. Joules per gram per degree Celsius. This is the unit. The unit means that for the A substance, 0.1 joules of heat needed of heat is needed to raise the temperature of 1 gram of substance through 1 degree Celsius. Right? Okay, Shri, we are on unit 6. Shri is asking some question in a private chat. So I'm just answering her question. She's saying that when we are going to start unit 7. So after finishing this, today I think we should be able to finish it. So tomorrow I'll start unit 7. Okay. But I don't think we can finish it by 13th, the date you are asking. Because then after tomorrow, the next class is next week. Okay. So is this definition of specific heat capacity clear? Now, if this A has a 0.1 joules per gram per degree Celsius, B, let's say 0.5 joules. This question we have already done. So I'm just giving you a review of this. Let's say I have given you 10 grams of A, 10 grams of B, the masses are same, and I'm raising the temperature of both of them through 1 degree Celsius, in which case more heat is needed. In which case more heat is needed. Yes. In case of B, how much? Can you calculate the amount of heat needed here, Sushant? Shrihan? No, it's 10 grams. This is for 1 gram. So for B, how much amount of heat is needed? 5 joules. For 1 gram, 0.5. For 10 grams, 5 joules. And for A, how much is needed, children? For A, how much is 1 joule? So the question can be in any form based on this definition of specific heat capacity. That is the reason I explained you this definition again. Okay. Ready to do this question based on specific heat capacity definition, meaning if you remember we did this equation Q equals to M C delta T. You know the meaning of everything. M is the, what is M? M is the, yes please. Yes, M is the mass of the substance in grams. What is this small c? And what is this delta T? Small c is specific heat capacity with the units of joules per gram per degree Celsius. Specific heat capacity. And delta T is change in temperature. And remember, change in temperature, delta T, you can measure in degrees Celsius or you can measure in Kelvin. It doesn't matter. Answer will be the same. I think I gave you one example to make you understand that difference in temperature in degrees Celsius or in Kelvin, the answer will be same because degree Celsius plus 273 is Kelvin. So when you take the difference, this 273 cancelled out. Yes. Okay. So based on this equation, now we are going to learn many questions. First, calculate the energy required to raise the temperature of 150 grams of silver from this to this. So here the mass is given, delta T is given, C is given. So they're asking energy. So use this equation. And your answer should have how many significant figures? Yes, please. How many significant figures? Yeah, delta T is 25. Very good. So how many sig fig in the final answer? Yes, only two. Only two. Can you see the answer is in two sig fig, right? Now let's see the B part. Ready for the B part? A part is done. And the units will be joules. Answer should be this. Ready for the B part? Calculate the energy required to raise the temperature of 1 mole of silver. This is called as molar heat capacity. And the molar heat capacity, which generally in the books written as cm, is actually joules per mole degree Celsius. That's the molar heat capacity. Joules per mole degree Celsius. Now, how much heat is needed to raise the temperature of 1 mole? So, do you know how much mass is there in 1 mole of silver? Look at the periodic table. Check the molar mass, atomic mass of silver. Silver is in the transition metals, copper, silver, gold. These are also called as coin metals, coin metals. They are used in making coins. So the molar mass of silver is 108 grams, right? Mass of 1 mole. So I'm going to use this equation, Q equals to mc delta T. But this time, this mass is 108 grams. C is same value which is written on the top. Delta T, how much is delta T? See two significant figures, 1.0. And you will get the answer. But now the units will be, this Q is joules per mole per degree Celsius. The amount of heat needed to raise the temperature of 1 mole of the substance through 1 degree Celsius. Any doubt in the B part? No? Ready for C? It takes 1.25 kilojoules of energy. So Q is given. This is Q in kilojoules. Pure silver, delta T is given. Oh, so simple question, right? Calculate the mass. So again, I'm going to use the same equation. Q equals to mc delta T. What is m? That I want to know. What is C is given 0.24. What is delta T? I can calculate. How much is delta T? 3.2. Thank you very much. Who is this last year? Very good. 3.2. Q 1.25 kilojoules. Kilojoules has to be converted into joules because you have to have this units compatible. You cannot take kilojoules for one quantity and joules for another. They should cancel out. So I'll convert this into 1250 joules. Right? I multiplied by 1000 and it is in joules. Calculate M. How many sig fig in the final answer? How many sig fig? Only 2. This has 2. Only 2. And you can see the answer is this. You can rearrange the equation. Like rearrange this equation. M, you want to calculate M? M equals to Q divided by C delta T. Make yourself expert in rearranging the equation. Like this is the equation. Q equals to MC delta T. If I want to calculate M, I can rearrange it like this. M equals to Q C delta T. If I want to calculate delta T, I can rearrange it like this. Delta T is Q over MC. If I want to calculate C, C is Q over M delta T. So they may ask you mass, delta T or C, identify the substance like this, these type of question. So I'm just rearranging this equation, right? Yeah, formula will be given to you in the exam. Yes, Shrihan, only this one, not the rearranged one, okay? Only this one will be given to you. Okay, now can we do the last question here? So mass is given, M. One of the substance listed here, we don't know the substance. Delta T is given. Delta T is given. What is this? 133 joules. What is it? Q, right? Is given. Yes, Q from the equation. And which substance was it? That means I want to know the specific heat capacity because table is here. If I know the specific heat capacity, I know the element. So what is the aim? Aim is to calculate C. So I'll use this equation Q equals to MC delta T. I will isolate this C and it becomes Q over M delta T. You just plug in the values and calculate C, right? So how much is C? You will get C somewhere around. Yes, Lasya, what is C? And how many significant figures? I think the answer should have 3 significant figures. Yes. Yes. And what is C? Anyone doing calculation? Only Lasya and Shrihan are interacting with me. Dhruv, you're there? You're not answering anything, Ashita, Dhruv, Sanjana, Saranya, Sarayu. No, 3 significant figures, Sanjana. You subtract this, you'll get 3 sig fig. Yes. Dhruv, where are you? You're not answering anything. 0.890 joules per degree Celsius. That's the right answer. See? Now check which element is this. Yeah, it is aluminum. Okay, Saranya. No problem. So we can identify the element by specific heat capacity. I think in the last class I told you specific heat capacities are like fingerprints. Like you have your unique fingerprints. These substances have their unique specific heat capacities. If you know the specific heat capacity of a substance by like this type of question, this type of experimental data, you know the element. right? So this question can be there. Okay, now if you remember, I told you about thermal equilibrium. What is thermal equilibrium? Yes, what is it? Heat flows from high temperature to low temperature till both objects or both systems attain the same temperature. Same temperature, right? This is the definition of thermal equilibrium, which is also called as zeroth law of the thermodynamics. This I explained you earlier also. Zeroth law of thermodynamics. Don't worry about this name, but you should know what is thermal equilibrium. Now read the question and tell me what will happen. There is 30 grams sample of water at this temperature. This is T1. T initial, you can say. This is mass of the sample. There is 50 grams of water. This is second mass of the another sample, another system. And this is the initial temperature. Calculate the final temperature, which according to thermal equilibrium will be same. It should be same for both of them, right? Of the mixture as assuming no heat loss to the surroundings. Yeah, what is this, Lasya? It's not a gas law question, right? So, Lasya, check your equation. It's not valid at all here. Okay, so what happens, children? Who is going to lose the heat? From which system heat will flow to another system? Which system? 50-gram system or 30-gram system? Which system is going to lose the heat? All of you, please try to answer. If you are not answering, then it means you are not understanding the question. One system is at this temperature, other system is at this temperature. Heat flows from high temperature to low temperature. So 50 gram is losing. So this particular system is going to lose heat. So I'm going to say minus Q lost. And who is gaining heat? Which system is gaining heat? 30 grams, this one. So, and then I'm going to use the first law of thermodynamics, that heat lost is equal to heat gained. This is the law of conservation of energy. Law of conservation of energy. I'm using that now to know the final temperature. So how we are going to do it? Q lost. I can calculate it by using MC delta T. I'm going to retain this minus sign here because it's losing. So understand, whenever you are calculating Q lost, it has to be with the minus sign. And what is Q gained? Plus MC delta T. What is M here? This is 50 gram, right? What is M? 50 grams. What is C? 4.180. 184, I think. 4.184. That will be given to you. What is delta T? Delta T. T final minus T initial. Initial is 330. Children, are we clear about this? Heat lost and heat gained. Now, can you help me with this equation, heat gained? The way I made heat lost, can we make heat gained? Help me in this equation. What is M? What is M? This time it is 30 gram because 30 gram is gaining. 30.0. C, 4.184. This one, same, water. Delta T. Now I want all of you to give me delta T here. Delta T. Delta T is T final minus T initial. How much is that? How come 50, Lasya? Do you know delta T? Do you know T final? Don't subtract these two temperature. The temperature, final temperature is not this. Lasya, the final temperature is not this. This was the initial temperature of this system. Yes. T final minus 280. That's the aim. Calculate the final temperature. You can take it as X also. Lasya, can you correct it? Okay, good. Very good. Now we have to solve it for T final. And it's not tough. Solving is not tough. Can you see these two numbers cancelled? They are same on other side of the equalities. They cancelled. Mathematical trick. And then you open this parenthesis. This minus is there. So minus 50.0 T final minus 330 is 30.0 T final minus 280. Now these zeros also we cancelled. Like these zeros, they cancelled. So now open this parenthesis. Minus, this is algebra, children. Minus 5TF minus minus will become plus this minus plus 0 1650, right, is equal to 3TF minus 28 multiplied by 3. $840? Yeah, thank you. $840, yes. Now this is the equation. I'm rewriting the equation. Minus 5TF so that you can see the equation. 1650 is 3TF minus 1840. Now we'll take this TF on the same side. I take this on this side. I bring this on this side. You know this algebra. So 3TF plus 5TF is 1650 plus 840. So 8TF is, what is this number? This one. This is 4, children. So 0, 9, 2490. And what is TF? 2490 divided by 8. Are you getting 311, children? 311. And answer is for 3 significant figures. Why I'm going to take 3 significant figures? You can check that these numbers have 3 sig fig. Even delta T has 3 sig fig. This number, see, 3, 3, 3, 3. So answer will be in 3 significant figures. So put the answer last year as 311. Check the answer. So children, this question is based on thermal equilibrium, that heat flows from high temperature to low temperature, and is also based on first law of thermodynamics, that's the law of conservation of energy, minus Q lost. Remember, whenever you are writing Q lost, you have to take this minus. If you don't take this sign convention, you will end up with the wrong answer. And the units will be Kelvin units. It's temperature, right? And this temperature, if you see, it should be between 280 Kelvin to 330 Kelvin. It should be in between this. If you don't take this minus, your this temperature will either it is above 330 or below 280 if you don't take this minus, right? So it is in between both the system. This system will attain thermal equilibrium and final temperature will be 311 K. Any questions here? Siri, you are understanding this? Lasya and Shrihan are interacting. I hope all of you are understanding. Very unique questions, very good questions. So taking you now on the next one. I hope you have written everything. This is question 55 from the Zumdal book, this one. Okay. Moving to the next question now. Now this question is based on, uh, again the same thing, thermal equilibrium and first law of thermodynamics. Read the question. But this time you have three systems, three. And all the three systems are placed together. So all the three systems will get the same temperature, final temperature. And that's what they are asking. And what are the three systems? I'm going to highlight the three systems. Aluminium pellets, aluminum metal, iron metal. Pellets means small pieces. And what is the third? Water. Now please read the question and I'll ask the questions and then keep answering. I will try to take out information from you. I'm not reading, okay? So you're going to give me the informations. Takes time. Read the question carefully. Observe the initial temperature, because from the initial temperatures you will decide who is losing and who is gaining. And now, can we start? Tell me, who all are losing heat? Minus Q lost. Minus. Who is doing it? Which two system out of three, who all are losing? Only iron? What about aluminum? No, Saranya. Sanjana, I think. Yeah. Sanjana, water is at low temperature. See, water is at low temperature. Water is gaining. Aluminum and iron are at high temperature. See their temperature. So when you put iron pieces, aluminum pieces at very high temperature into water, which is at low temperature, heat flows from iron pieces and aluminum pieces to water. So Q lost is because of the aluminum and Fe. Any doubt here? And who is gaining heat? Who is gaining heat? Which system is gaining heat? Water. So this is the first law of thermodynamics which I'm going to use here, right? I'm going to retain this Q negative sign because if I don't retain it, I'll get the wrong answer. So minus retained, right? Now Q lost is aluminum and Fe. You know that Q is equal to mc delta T. I will assume the final temperature, this final temperature, I can assume X. All the three systems are finally at the same temperature, thermal equilibrium. So Q lost by aluminum is mc delta T of aluminum. Q lost by Fe is mc delta T of Fe. And put big brackets. Big brackets. Outside the bracket minus sign because they are losing. Both of them. This is the total amount of heat lost. Total. By aluminum and Fe. Is equal to, what's the equation here, children? Gained means plus. What's the equation? Yes, Siri. Equation. Yes. Nasya. How to calculate this Q gained? Same. Same equation, isn't it? mc delta T of water. Yes. For delta, you can write like this. I can understand. Okay, so just write mc dt. I'll understand. For water, yes. You're understanding this? This is the first law of thermodynamics. Energy can neither be created nor be destroyed. It can be transferred from one place to another, from one substance to another substance, or it can change the form also. So the amount of heat lost and gained are equal. Now plug in the values. Ready? What is the M of aluminum? M of aluminum. Read the question. Give me the mass of aluminum. Yes, 5.00 grams. C of aluminum is given in the question. Is given in the question. C of aluminum. 0.89 in the question. Delta T, here, C is given. Delta T. I'm assuming the final temperature is X. Delta T is T final minus T initial. So what is delta T, children? If the final is X. X minus, what was the initial? Initial temperature. X minus 100. You are taking water. Shrihan, you have taken water. So, children, you are unable to read the question properly. I gave you time. Okay, this is aluminum, right? This is aluminum. Get the Fe. This is aluminum. Get the Fe. Plus Fe. What's the mass of Fe? Mass of Fe, children. What is this 55.845? Mass of Fe is this 10.00 gram. Please read the question carefully and answer my questions. What is C? Yeah, it's given in the question. What is delta T? Delta T. Final minus initial. Delta T. Again, you are taking water, Shrihan. Why you are taking water? You have to see this. If you are doing error here, you will do error in the exam also. Why are you taking water? 22 is for water. Water. Shriyan, correct yourself. What is M? For water. Now this is for water. What is M? M of water. Is 97.3 grams. Specific heat capacity of water. It will be given to you in the exam. Delta T of water. Delta T of water. X minus 22 this time. Yes. Okay. Now you can see it's an algebraic equation. Solve it. Put this minus outside and solve this. How much is this? You can use your calculator. Okay. 4.45. Shreya is giving me this value as 4.45. Please check it. And what is here? X minus 100. Right? How much is this? This one is 4.5. X minus 100. Close this bracket. How much is this? How much is this? 407.10, right? The value given by you is correct. I'm dropping the rest of the digits. X minus 22, right? Now you can solve it. Open this parenthesis. Keep this minus here. 4.45 minus 4, this is X multiplied by this X minus 4, 445 plus 4.5x minus 450 is equal to 407.10x minus multiplied by 22. And that value is 8956.27. Okay, can you see? Now the equation is simplified. Add these two, this one with this one. So it will be 8.95. I'm writing equation here in this black part because there is no space there. So I'm working here. So I'm simplifying it. I'm adding these two. It becomes 8.95x. And I'm adding these two, 445 and 450. They have the same sign. So they will be added. 445 and 450. They should be added because they have the same sign. So minus 895 is equal to 407.10x minus 8956.27. Can you solve it for x, children? Just solve this equation for x. Algebra. Yes. 398.05x is equal to, yes, please do it fast. So I'm just doing in simple manner and getting the value of x. Are you getting this answer, children? Yeah, somebody has reported the answer and that is very accurate. This one. Okay, Shriyan. I was not doing calculations very seriously. So, children, those who are reporting 23.68, they are right because this is the answer. So, the temperature is closer to water or closer to iron and aluminum? Remember the initial temperature of Fe and aluminum was 100 degree, right? And this temperature is dropped to 23.7 degree. And the water temperature was 22 degree. And this temperature is raised to 23.7 degree. So there is very high drop in the temperature of iron and aluminum, but there is a very slight rise in the temperature of water. Why? Because of the difference in the specific heat capacities. Iron and aluminum have very low specific heat capacity. So with when the heat starts flowing, more heat is flowing, showing you more drop in temperature. Oh, sorry, with a small amount of heat flowing, there is more drop in temperature because specific heat capacity is very small. Shirian, you have to redo the calculation. I think somewhere I didn't pick up the right value, and maybe that's why the answer is there. But answer is this only. This is the correct answer. And we must have done some error in the calculation only. Okay, so redo the calculation and you get the answer. Okay, so here you can see that you have to retain this minus. It's very important to retain the minus sign. Only then you will get the right answer. Okay, ready for next question? This one. So something like this only. Let's do it very fast. Read the question carefully. There is a metal. We don't know the metal. Which metal is that? We don't know. And there is water. Water we know. The mass of the metal is given. The initial temperature is given. The mass of the water is given. Its initial is given. The temperature of the water rises. Calculate the specific heat capacity. Now read the question, please. Take your time. There is a metal. There is water. Metal is dipped in water. Metal has a different initial temperature. Water has a different initial temperature. When the metal is dipped in water, heat flows from where to where? Who is losing heat here? Metal or water? Answer this question. Which system is losing heat? Metal or water? Metal is losing heat because metal is at high temperature. And water is gaining. So minus Q lost, which is metal, is plus Q gained, which is water. Do you know the final temperature here? Do you know the final temperature of both the systems? Or do you know the final temperature of water? Yes, final temperature of water is this 18.3. This one. So it means we know the final temperature of both of them because they are together, thermal equilibrium. So this is the final temperature for the metal also. Now plug in the equation. mc delta T for metal. mc delta T for water. What's the mass of the metal? 150.0. C. Do you know the C specific heat capacity of the metal? No. Just take it like this only. Do you know delta T? Yes. It is 18.3 minus 75.0. Final minus initial. This is the amount of heat lost is equal to gain by water. Mass of the water is 150.0 grams. You can see here. Sarayu, you are there? C of the water is 4.184. Delta T is, what is delta T? 18.3 minus, what was the initial? 15.0. Can you solve it for C, children? Sarayu is there? Yeah, she's there. So Sarayu, can you solve this algebra equation for C? Just subtract this, get this value, and rearrange everything. Oh, the masses are same, cancelled. These masses are same. See, 150, 150, cancelled. So you have 4.184 times this difference, which is 3.3 divided by this difference. And this is a minus and this is a minus. Minus minus will become plus. Okay? Minus minus will become plus. This minus and this minus plus. So I'm getting 5.65. So, no, 56.7. Get this answer. And give the answer with the units. Is the specific heat capacity. So you will put your answer with the units. You know the units of specific heat capacity is 0.24. How many sigfig? 2. You see, when I'm taking this difference, the answer is 3.3. That's 2 sigfig. So 0.24, that's it. Units, joules per gram. Sarayu, can you type the units? Give the answer with units. Type it, learn it. Do the things for learning. Okay. Now which element? Identify the element. Identify the element. The table is here. Identify which element is this. This value is closer to the specific heat capacity of which element? Silver. This is silver, children. Okay. Moving on. Now, in these questions, we were using the simple applications of thermal equilibrium, heat lost equal to heat gain. There was no chemical reaction. Remember, in all these questions, we were not carrying out any chemical reaction. Now, We are going to do a chemical reaction in a coffee cup calorimeter. So I told you about the coffee cup calorimeter. It is made up of thermocol. It's like a coffee cup. It has a lid on the top so that heat cannot escape. There is a thermometer, dipped thermometer. There is a stirrer, and you are going to carrying a chemical reaction. You are going to do a chemical reaction in the aqueous condition. Generally, aqueous reactions are carried out, and you are going to measure delta T. And you will use this equation Q. In the coffee cup calorimeter, generally the reactions are in water. So water is the major thing here. So you can call it the system is of water. Q water as MC delta T. You will use this equation to calculate Q of the water, this water. So we'll read the question very carefully. We'll see how can we calculate Q of the water from the information given here. And then they are not asking that. They're asking what is the heat changes during this reaction. They're asking delta H. They are not asking Q water. This is the system. The reaction is the system. And water is the surroundings, right? What is water? Surroundings. So don't you think that the amount of heat gained or given by surroundings is exactly same as the amount of heat transferred from the system, from the reaction? So if I know Q of the surroundings, the change in heat of the surroundings, I know of the system because we know that Q system is here, reaction. Q reaction is minus Q water. I'm going to use this equation to know the Q reaction because that's the question. But the question is not asking Q reaction. They're asking delta H reaction. But delta H reaction is Q reaction divided by number of moles, kilojoules per mole. Kilojoules per mole or joules per mole, see, per mole. And this Q reaction you can replace by Q water minus Q water over N. I will use this concept in this cup calorimeter experiment. We are carrying out a chemical reaction in cup calorimeter. Please read the question carefully and give me the information and work with these equations. If they are not clear, keep asking questions. Remember, in cup calorimeter, water is the surroundings and system is the reaction. And you are measuring temperature, delta T. You are measuring of what? This delta T, this thermometer is dipped in, it is dipped in water. You are measuring delta T of the water. Remember that. So that is the reason you will calculate Q of the water. That's what you are going to calculate by using MC delta T. That's the information about cup calorimeter. Can you read the question carefully? Pay attention to every line. You know, you need moles. You need moles. From here, you will get the moles. You'll come to know that how many moles of AgCl are formed. Right? So get the moles. So Ag plus, which is actually AgNO3, See, they added AgNO3. This is net equation, net ionic equation. Reacting with HCl, giving you AgCl solid plus HNO3. They have given the net ionic equation. Can you tell me initially when you started the reaction, how many moles of silver nitrate you have added? You know that, right? How many moles of silver nitrate we have added? Please answer that. You know this equation. Molarity is moles divided by volume in liters. So how many moles of silver nitrate we have added? Yes? You don't know how to do this? I'm asking you to calculate moles. You have the molarity. You have the volume. So moles equals to, please answer fast so that we can move fast. Molarity times volume. Unit 3, unit 4. We did plenty of question based on this equation. Unit 8 is based on it. These are millimoles. Siri, you are giving me millimoles. She's giving me millimoles because she didn't convert milliliter to liter. Shri, can you see that in the definition I have taken volume in liters? So if you take volume in liters, then it is 50 divided by 1000, 0.5, 0.5 multiplied by 0.1, so 0.05, right? How many millimoles of HCl? Moles, sorry, you can work with the moles here. How many moles of HCl? See, these are moles. I'm calculating moles because I need moles. See, answer should be in moles. That's why I'm calculating moles. Initially, any AgCl? No, no. Finally, what will happen? Who is the limiting reactant? How they are going to react? They are reacting 1:1. So 0.05 will react with 0.05. Unit 4, children. This is 0. Finally, how much AgCl is formed? 0.05. How much HNO3? 0.05. But you are interested in AgCl because in the question they are asking that how much heat delta H kilojoules per mole for AgCl. So I know N. N is 0.05 moles. From this equation, from the molarity, volumes, I calculated the moles of silver chloride formed. Unit 4, Unit 3. Now let's start reading further. Now let's take out another information. Two solutions initially at this temperature, both the solutions are at the same temperature. They are not at different temperature. They are mixed. One solution is of this, another solution is of this, 50 ml of AgNO3 mixed with 50 ml of HCl. And there is a change in temperature. So do you know delta T, children? Please answer. Those who are not answering, I'm not sure whether they are understanding this. Delta T. Delta T for water. This is for water because this 50 ml means 50 ml of water. Delta T. What is delta T? T final minus T initial, which is 23.40 minus 22.60. Yes, children? Anyone doing calculations? Sarayu, what's the answer? Ashita, you're not answering anything. Ashita is in this course? Yeah, she is. Yeah, please answer. What's the difference here? Give me delta T. And you will take answer up to 2 decimal places. Significant figures rule. So it will be 0.80, right? Now, is the mass of water given? Mass of water, mass of the solution is 100 grams. So they are saying take the mass of the solution as 100 gram, 50 plus 50, 100. And density of water is 1 gram per ml. So generally, the volume, the sum of the volumes is the mass of water because density is 1. So mass over volume is 1. So it means mass equals to volume for water. Density of water, this we have done earlier, is 1.0 grams per ml. This is for water. So mass over volume is 1.0 grams per ml. So it means mass equals to volume. And the volume is 50 plus 50, 100. So mass is also 100. That's they are writing it also here. So can I calculate Q? What water is doing, children? Is water gaining or losing? Is there a rise in temperature or drop in temperature? You are measuring delta T for water. This delta T, is it rise in temperature or drop in temperature? Please answer. I'm waiting for the answer. Water is gaining or losing? Mm-hmm. Sarayu, is water gaining heat or losing heat? Is the temperature of water going up? If you are unable to answer this, what you are listening, children? Dhruv, you are not answering today anything? Are you busy in something? Dhruv, then you are not answering anything. I cannot see your name in the chat. Children, I have planned to share the chat messages with the in the group WhatsApp group so that you can see that how much interaction you are doing with me. Okay. So all the chat messages they get saved in my computer with the video. So I share the chat messages of every session so that I want you to analyze how much interaction you are doing with me. Sitting silently is not a solution. No, no, Dhruv is not for you. It's like many children are not answering today. Only Lasya, Siri, and Shrihan, only few of you. For others, I have to call the name. That's not good. Okay, so please, I'm going to share the chat messages and please analyze that how much you are interacting with me. This class is not just sitting and thinking something else or watching something else on the computer. So there is a rise in temperature. So water is gaining heat. It's gain. So it should be positive. What is the mass here? Mass of water, 100 grams is given. What is C? 4.184. What is delta T? 0.80. And you'll get your answer in joules. How much is this? And take your answer up to 2 significant figures because temperature delta T is in 2. So I'm getting 300 34 334.72 joules. I had to put it in two significant figures, but that's not the final answer. Final answer is delta H. So keep it like this only. You can write it like this also, but I'm just avoiding too much approximation because this should be my final answer, delta H reaction. So what is delta H reaction? Is minus Q because water is gaining, so reaction is losing. So heat is coming from the reaction. So minus this value, and finally you put your answer in two significant figures. N is how much? We calculated, right? 0.05 and put this answer. This answer is in joules per mole. How much is this? I'm getting 6694.4. But they're asking answer in kilojoules per mole and up to two significant figures, and there is a minus sign. So convert this answer into kilojoules and two significant figures, and you will get your answer as minus 67 kilojoules per mole. When you drop 94, it will become 67, right? Though here the answer is represented here is minus 66, so there are up to one digit is things are acceptable because this is the uncertain digit, 7 and 6 here and 7 here. So that much error is okay. So you're understanding this question? Can I just give you a review of the question, those who are not paying attention earlier? So there is a coffee cup calorimeter. From this part, can you tell me what information you derived? What information you derived from this part? Sarayu, what we calculated? We calculated the moles, right? By using molarity times volume in liters. We calculated moles of HECl, which was 0.05, if you remember. Then from this part, you observed delta T. Delta T, the temperature is going up, means water is gaining heat. From there, you use the equation mc delta T. You have the mass of the water, which I explained you that density of water is 1 gram. So mass is generally volume. You have the C. C is 4.184. That will be given to you. You have delta T, this one. And this Q of the water is surroundings. And the answer will come in joules. You convert that into kilojoules. Then you are using equation that delta H of the reaction is minus Q of the water over N. Because water is gaining, so reaction is losing. So your delta H of the reaction will have a negative value, negative 66 or 67, which we calculated. Negative means reaction is exothermic. Is it okay? Again, only Shrihan and Lassia are more interactive. Children, this question, if you are unable to understand here with me, then take it that you won't be able to do it in the exam. Okay, ready for another such question? Read the question carefully, very carefully. We are going to use these equations. It's a coffee cup. So we are clear that I'm going to use this equation QH2O MC delta T. I'm going to use this equation delta H reaction is minus Q water over N. I need to know N of this. So what are you doing here? you are dissolving ammonium nitrate, completely soluble in water. You are dissolving ammonium nitrate in this much grams of water. The initial temperature of water was this, but after dissolving, you are getting the final temperature like this. Is the temperature going up or going down for the water? This temperature is going up or going down? Is going down. So water is losing, right? Water is not gaining. Water is losing. And who is gaining? Who is gaining? Ammonium nitrate. So ammonium nitrate is undergoing dissolution. Unit 3. We did the solubility rules. When added in water, it will become ammonium. It's a strong electrolyte. Is going to dissociate completely. Unit 3, Unit 4, ammonium nitrate completely soluble. It will break down as ions. It's a strong electrolyte, right? So this is what is happening. And they're asking you to calculate delta H naught of dissolution, right? And you know that delta H naught of dissolution is minus Q of the water over N. Do you know N? N is the moles of ammonium nitrate which you have dissolved. That is 1.60 grams of ammonium nitrate, the given mass here, divided by its molar mass. What's the molar mass of ammonium nitrate, children? Molar mass of ammonium nitrate. Answer these simple questions so that you should remain active. Your brain should remain active. I calculated faster than you. 108.32. That's the molar mass. You divide grams by molar mass, which is grams per mole. You'll get your moles. How many moles are there? And they should come in 3 significant figures. Is it 80? I did some error. Oh, I think I took nitrogen twice. Yes, I take your molar mass. Is 80.04. Okay. Get the moles. Get the moles, children. Zero point 0.0199, which can be written as 0.0200. 3 significant figures. See, this number has 3. These are the moles, right? 3 sig fig. These are 3 sig fig. Leading zeros never counted. Leading zeros are never counted. Okay, now we have the moles. What I need? Q water. So what is Q water? Plug in your M here. M is, now this time, this question has a different approach. When you add ammonium nitrate into 75 grams of water, M changes. M of the solution is, I'm going to use this equation, but I'm going to take it as 75.0 plus, because this is the part of the solution now. So most of the children, they do error here. 76.60 grams. You're going to add the mass of the ammonium nitrate because now it has become the part of the solution. So this will also going to show you rise and fall in temperature. So M is 76.60. C is, they are saying use this 4.18. Delta T is 25.00 and 23.34. This is final, children. So keep it in front. 23.34 minus 25.00. You'll get a negative answer. Definitely, because Q is water is losing heat. So Q has to be negative. And you're getting a negative answer, children. How much is this? Anyone helping me with the calculation? Dhruv? Dhruv, can you help me with the calculations? Okay. Sri is saying it is minus 531.51. Even if you're not understanding some confusion, you're not asking question, keep helping me with simple calculations, simple things. You will see that it will involve you, it will make your brain active. Is this right, Nasya? This answer, Dhruv, is it right? Okay, good. So that's the Q of the water. But what we are aiming, we are calculating delta H of the reaction. That's the aim. Delta H of the dissolution. This one, this is the aim. Dissolution, why we are calling it as dissolution? Because we are dissolving ammonium nitrate in water. So delta H's, they get the same name. Delta H of neutralization, sublimation, condensation, depending upon what type of change is taking place. Accordingly, you can give the name, and that is minus, this, and then this minus 531.5 joules. This is in joules, right? Divided by moles. Moles we calculated here 0.0200. Get the answer, convert that into kilojoules because they are asking answer in kilojoules per mole. In some questions I have seen that they are asking answer in kilojoules per gram. How to do if they are asking in kilojoules per gram? I'll give you another equation. Can we do this? Can you give me the answer in kilojoules per mole and can you check, are you getting this? And it should be positive because ammonium nitrate dissolution is endothermic. When you put ammonium nitrate in water, it is an endothermic process. It takes heat from water, temperature drops. Are we getting this, children? Go for three significant figures, right? If I go for three significant figures, Dhruv, it's not minus now. Is it minus? Can you see two minus here? One here, one here. One minus from here, from the equation, this one. And one minus in calculation here. If water is releasing, then ammonium nitrate is gaining. Answer is positive. Plus 26.6 kilojoules per mole. Okay, now I'm changing the question, children. I'm changing it. Rather than answering in kilojoules per mole, in the exam, they are asking kilojoules per gram. Any one of you? How to do this? How to calculate kilojoules per gram? Do you know the total amount of ammonium nitrate dissolved? 1.60. Then delta H naught dissolution. I'm going to use this equation, children. I'm writing here just to make it more clear. I'm writing here on the black part. over here. Delta H naught dissolution of this ammonium nitrate will be minus Q water divided by mass of ammonium nitrate. So I will not take moles now, I'll take mass. Yes, I'm not going to convert moles to grams because gram is already given. Shrihan, why should I do that? It's given. And I know Q water, which I calculated here. See this one? So minus 531.51 divided by, and there's one more minus, right? Two minus. There's a minus here. Minus minus will become plus divided by 1.60 joules per gram. You can convert joules to kilojoules and you'll get the answer. So please take care of this equation also. Somehow I've seen this question in one of the paper that they are not asking kilojoules per mole, they're asking kilojoules per gram. Okay, so CD is giving me 332 kilojoules per gram. Is she right, children? This is not kilojoules. See, this one is joules. This energy which you calculated here, it is in joules. So the answer which you have given me is joules per gram. These kind of questions last year will be in free response also. I've seen them. Plenty of them are in free response. You have to show the work. You can practice more such questions on the website and on this on the book which I'm sharing there. So the answer given by Siri is 332, but that is in joules per gram. So when you convert that into kilojoules, it will be 0.332 kilojoules per gram. So units are important, children. So please pay attention to the units. Check what unit they are asking in the question. Okay, ready for next? The next topic is bomb calorimeter. Yes, Shrihan. If you want to calculate delta H of the reaction by using cup calorimeter, then it is always minus Q of the water over N. Even in bomb calorimeter, this is bomb calorimeter. This is called as bomb calorimeter. Even in this, you will use this equation. So what's the difference between bomb calorimeter and cup calorimeter? If you see cup calorimeter is like this. You're taking water here. There is a thermometer dipped in water and there is a stirrer. Stirrer is needed. Stirrer is here also. You can see the stirrer here. Stirrer is needed for the uniform spread of the heat. If reaction is losing heat with the stirrer, you can make it uniform spread, right? So stirrer is the part of the experiment. This coffee cup calorimeter, the pressure outside is 1 atm outside and the pressure inside is 1 atm. No change because it's a coffee cup. If you change the pressure, then even the cup will break down or it will squeezed up. So coffee cup is at constant pressure. At constant pressure. That is coffee cup. You are calculating QP. QP is heat at constant pressure, right? So remember, the coffee cup is at constant pressure, but the bomb calorimeter is not at constant pressure. Pressure can increase and it can blast. So that's why the word is bomb. Here the pressure will be increasing many folds. Of course, it's not blasting because we have taken a very strong steel container. This one. The reaction is carried out in a steel container, very thick wall of the steel. We call it a steel bomb because here we are carrying out a chemical reaction, gases are generated, pressure increases many folds. So generally here we carry out the reactions like combustion. Combustion reactions. In combustion reactions, a large amount of heat is generated. Can you carry out combustion reaction in water in cup calorimeter? No, you cannot carry out. You cannot do combustion in the water, right? You need a dry place. So for combustion reactions, we use bomb calorimeter for the reactions which cannot be carried out in water. Cup calorimeter is aqueous reactions. Aqueous means in water, like acid-base reaction, neutralization, precipitation. We took one example of silver nitrate with hydrochloric acid. We did one question. So that type of reactions can be carried out in your cup calorimeter, the one which are happening in water. But there are many reactions which we don't carry out in water. For that, we will use bomb calorimeter. Is it okay? So what is bomb calorimeter? It is a constant volume. Volume is not changing. If volume is not changing and pressure is changing, so definitely pressure will increase. So that's why we call it as bomb. So I'm going to make a simple diagram from my side to make you understand how it works. All eyes here on the whiteboard. We are making a bomb calorimeter. We'll take a steel capsule and we take a container, this container. This is the steel capsule. We carry out our reaction in this steel capsule. Reaction is carried out here, reaction. There is no water inside. By using some electric spark, can you see this electricity? So I am using some electric spark to ignite it, to ignite the reactants. And around this steel capsule, there is water. This is water. In a closed container, it's not open. It's closed. How much water is there? We don't know because it's closed, completely closed. Can you see this water here? Water. We don't know the amount of water because it's completely closed container. And then around this, there is another layer like this. This layer is completely insulated. So I'm going to show you with a different color. Insulated means heat cannot escape. This is your bomb calorimeter. What else is needed? A thermometer. Where it should be? In the water. Thermometer is in the water. This is thermometer. You're going to measure delta T here. Change in temperature of water. Water in the bomb calorimeter. And then you need a stirrer for the uniform spread of the heat. Can you see thermometer? The stirrer, they are in water. You can see the bomb. So where are you carrying out the reaction? Here. Here is the reaction, the combustion, whatever reaction you're doing here inside. And around this container, this steel bomb, there is water, plenty of water. I can use this equation Q of the water equals to mc delta T. But there is a problem. What's the problem, children? Can I use this equation? Is something missing? Yeah, what? The mass of water. I don't know. It's a closed container. When you go in the lab, your teacher will give you, oh, this is bomb calorimeter. Carry out your reaction and calculate delta H of the reaction. So she has given you this task, calculate. But she has given you bomb calorimeter, no more information. So it means you don't know M. If you don't know M, then the equation changes. So what's the equation I'm going to use here? In this bomb calorimeter, I'm going to use equation Q equals to Q of the water. We are going to measure water. Thermometer is in water, delta T. It is in water. So Q of the water, C delta T. And what is this C? This C is M times small c. What is M? Mass of the water. I don't have this information, mass of the water. So I'll calibrate my instrument to know this C. I can know this C. And this C is now called as, it's not specific heat capacity, it is heat capacity. Heat capacity of the bomb calorimeter. Of the bomb calorimeter. Children, you are clear that why I cannot use this equation? Are you clear about it? Because we don't have M of the water. That's why. Okay, so I have to use this MC as C. I can calculate C by using calibration method. So I'm going to do some questions with you where we are going to calibrate our instrument. Yes, Dhruv is asking how this C is different from this small c. Can you just give me the units of this C? What are the units? Rearrange the equation. C equals to, this capital C is equal to Q over delta T. I'm rearranging. So what are the units of this C? Joules per degree Celsius. There is no grams, right? And what were the units of the small c? If you remember, joules per gram per degree Celsius. Now this is for 1 gram of water. Here grams are involved, here not involved. So actually what is the meaning of this C? The meaning is when you take any bomb calorimeter, every bomb calorimeter has some amount of water here. They can have different amounts. It can be big, it can be small. So they have some amount of water. Even the valves, the thermometer, the stirrer, they all are going to gain or lose some heat. So that all are included in this C. That all I can include in this C. Heat capacity. It is the how much amount of heat needed to raise the temperature of this bomb calorimeter. Mass is not involved. See the definition. The amount of heat needed to raise the temperature of this bomb calorimeter through 1 degree Celsius. It doesn't matter how much amount is there. And this one, amount of heat needed to raise the temperature of 1 gram of water through 1 degree Celsius. This one, heat needed to raise the temperature of that bomb calorimeter, this bomb calorimeter through 1 degree Celsius. Is the difference clear, children? Yes, Dhruv, is it okay? Ready for the questions? I hope all of you are listening. If you are listening, give me the units of this heat capacity. All of you, please type the units of heat capacity. Yes? No one? Only Dhruv? What about others? You don't want to type? What's the equation we are using in bomb calorimeter? Equation we are using. Q equals to C delta T. That's the equation we are going to use. Very good. Sanjana. Perfect. Okay, and what is the name of this C? What is it called as? Name. You can check the question asked by Dhruv. Heat capacity. Yes. This thermometer is going to tell you delta T. Are you going to measure the delta T of the bomb or of the water or of the reaction? What delta T you are measuring? This thermometer is in the water or in the reaction mixture, where it is. What are you calculating? Of the water. Yes, Q water. Q water is C delta T. What is this water? Is it the system or the surroundings? Water is system or surroundings here? Surroundings. Who is the system? Yes, Ashita, what is the system? The reaction is the system. And we know that according to first law of thermodynamics, Q system is minus Q surroundings, right? But system here is reaction, reaction. And surrounding here is water. I want to calculate delta H of the reaction. What's the difference between Q reaction and delta H reaction? Any one of you? What's the difference between this and this? It is just in joules or kilojoules, no per mole, right? This is in joules or kilojoules, but this has to be in kilojoules per mole or joules per mole by definition. Delta H, how much heat per mole, and Q, just the amount of heat. Are you getting the difference? If I want to calculate delta H of the reaction, then it is Q of the reaction divided by N. But I'm not measuring Q of the reaction here. What I'm measuring? Q of the surroundings. I'm measuring water. So it means minus Q of the water divided by N. If all these points are clear, are you ready for the questions, children? Anyone having any problem here? Sarayu, you're not interacting. Sarayu, you heard everything clearly? Okay, fine. Questions now. Okay, good, Lasya. Lasya is interacting with me from starting only. Children, please don't make me call your names. You are sincere students. Okay, if you're sitting here for 2 hours with me, not for my voice, right? You're here for learning. So memorize with me. I'm trying to make you understand and memorize also. I'm trying my best. Okay, so pay attention, try to answer simple questions, be interactive and memorize here only. We don't have much time. Okay, 67 question. This one is based on bomb calorimeter. The heat capacity means that capital C, this one, was determined. You know that you don't know the value of mass, so you have to determine. It's called as calibration. By burning 6.79 grams of methane, this methane, in a bomb calorimeter. Delta H of the combustion of this methane, sorry, delta H of combustion of this methane is given per mole. Temperature changed by this. This is delta T, A part. What is the heat capacity? Yes, children. So Q of the water is capital C times delta T. Delta T is given. This delta T is of the water. But what is Q of the water? They're asking me to calculate C, so at least I should know this. Then I'm going to use my another equation. Delta H of the reaction is minus Q of the water divided by N. I'll use this equation to calculate Q of the water. This one. Agreed? So you rearrange this equation and you will see Q of the water is minus, this minus will go on the other side, delta H of the reaction times N. N will come in the numerator here. But do you know delta H of this reaction? Yes, it's given. Can you see it's given? But it is given for how many moles? That's the question. N. Calculate N. What's the N, children? N of methane. You're doing combustion of methane, this methane. Methane is also called as natural gas, compressed natural gas, CNG, which is used in India in the vehicles also. It's also called as green gas. It's like the pollution is there due to methane also, but less as compared to gasoline and petrols. So it's a very popular gas, methane, natural gas. Okay, now get the moles. Moles will be 6.79 grams divided by the molar mass of methane. How much is that? 4 plus 12, 16. 16.04. How many moles? I need the moles of methane which are undergoing combustion. 0.4233. Anyone doing calculation? I'm teaching, I'm doing calculations, I'm doing everything, children. I'm checking also that whether you are doing it or not doing it. Minus delta H reaction. Delta H reaction is this. It's also minus, and there is a minus. So take this minus here, then take this minus also, because water is going to gain. Reaction is exothermic, but it's going to be endothermic for water, multiplied by N, which is 0.4233. How much is this? And this answer is positive because water is gaining. You see, there's a rise in temperature. And this answer is 339.5 units. Yeah, 339.5 units, children. Kilojoules. See, I didn't change this unit. Kilojoule. This was kilojoules per mole. This is mole. Mole cancelled. Kilojoules, right? Now, what is the aim? To know the C. That's the question. Heat capacity. So I know Q of the water. So Q of the water, I know, I calculated, is C times delta T. Rearrange this equation. C is equal to Q of the water divided by delta T. Q of the water is 339.5. Delta T is 10.8 kilojoules per degree Celsius. Are you getting this answer? No. Final answer should be. We'll work with the final throw. I'm not going to correct my sig fig here. I'll keep my sig fig in the mind that this should be 3, but I will do approximation in the final only. So this answer you can see is 3 sig fig, 31.5, right? So generally they say that apply sig fig rule in the final answer, because if you keep doing approximation, keep applying sig fig at every step, you'll get plenty of error in the final answer. How much is this? We are getting 31.5 kilojoules per degree Celsius. So can you see that we calculated the heat capacity of our bomb calorimeter from some reaction in which we already know delta H of the reaction. Like here, combustion of methane. We already know delta H of the reaction. We use that to calculate heat capacity. Now I know the heat capacity. I'm ready to do another experiment in the same bomb calorimeter because I know C now. This is called as calibration of the instrument. Calibration of the instrument. Without the heat capacity, you cannot use it because you are going to use this equation, this one. If you don't know C, how you are going to use it? How you are going to calculate Q water? If you don't know Q water, how you are going to calculate delta H reaction? So knowing this C value, the heat capacity is very, very important. Nasya, ready for this B part? Okay, good. So this one is, Sarai, you are not answering. This is A, right? Sarai, you are there? Okay, let's do the B part. Let's do the B part with me, Sarai. Same bomb calorimeter is written here. Same. Same means heat capacity is same. 12.6 gram sample of acetylene. Acetylene is a highly combustible gas. You know, you have seen people doing welding by using torches, welding torches. Like if there is some crack somewhere, so they are using their welding torches. That welding torch has this gas, C2H2. Can you see that how much heat it can generate on combustion? Welding torches are made up of acetylene gas. They are called as acetylene torches. So they are saying it's going to produce a temperature increase. So we know delta T, 16.9 degrees Celsius. Same calorimeter. So I can calculate Q water because this is the heat gained by water. So it is C delta T. What is C? It's the heat capacity which we calculated in the A part. For the same bomb calorimeter. What is delta T? 16.9. So now you can see that this question has become so simple now. B part. I'm just reading, taking out the information, plugging in the equation. How much is this answer? And don't worry, I know that it has to be in three significant figures, but we'll try to be accurate because they're asking delta H of the reaction. I have to calculate delta H. So it is, yeah, 532.35 kilojoules, right? Kilojoule. I'm using kilojoules. Degree Celsius cancelled. That's not the answer. They're asking me energy of combustion in kilojoules means delta H reaction, which is, can you give me the equation, children? How it is related to Q water? I've written it 2, 3 times. Delta H reaction is minus Q water. Who is this? Dhruv. Very good, Dhruv. Divided by N. And what is minus Q water? Is here. Take this minus and put this value 532.35 kilojoules. What is N here, children? Any one of you? What is N? What's the meaning of N here? Sarayu, what's the meaning of N? Yeah, moles. Do you know moles, Sarayu? How many moles? Moles of what? Moles of acetylene. I'm using an acetylene torch. So the moles of acetylene will be the mass of acetylene which is given, which the one which you have placed in that bomb. You remember bomb of the bomb calorimeter? The steel container in the center divided by C2H2. How much is this? 24 plus 2, 26. What's the answer? Zero 0.48. Now you can go for, oh, no, not now. We'll go for correct significant figures here. Plug in this value here. 0.4846. Answer should be in three significant figures because delta T is in 3, this is in 3, all these measurements are in 3. So put your answer in three significant figures and give the correct units with the correct sign. So if I have to put my answer in three significant figures, I'll use the scientific notation. Units, kilojoules per mole. This is mole. And still my answer is wrong. Why? Minus. It's exothermic combustion. This is the answer. I did some error. Yeah, it's 3, not 2. I cannot see numbers very clearly in my calculator. That's why I'm slightly lazy in using calculator, asking you to help me. But I think you people are more lazier than me. Are we okay? So this is the question based on bomb calorimeter. In the bomb calorimeter, you have to calculate the heat capacity. Very good, Dhruv. Be very hardworking children. You will like it. When you work hard and when you see back, you feel so satisfied. Okay. So right now you have 2, 3 months. Work very hard. It will be a landmark in your life. that, oh, I scored 5 in AP. And the credit goes to you only, not to me, not to the teacher. I never take any credit of 5. Many of my students, they get 5. But I never say that it's because of me. No, it's not because of me. If a student is getting 3, that you can say because of me. No, 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 no. I work very hard. I try to do everything. I give you all the examples, questions. In the review classes, I will be very, very intense in the review classes. You're going to have 30 review classes with me, and it will be like you will start crying. It will be so intense. So, from my side, I work very hard. And if you work very hard, credit goes to you. If you get 5, it's just because of you. If you get 3, it's just because of you. Okay, children? So please work hard. Work hard so that you can feel proud of yourself. After 10 years, 20 years, you'll be telling people, oh, I was 5 in AP chemistry. I worked so hard. Okay? So it's very important that you have to understand this. So we are done with bomb calorimeter and cup calorimeter. How much time is there? Can we do this question? Yes, 5 minutes are there. So we'll read the question and I explain you. Tomorrow in the class, I'll do heating and cooling curves. And then I'll start unit 7. I think, Sri, you were asking for unit 7, right? So somehow I cannot cover this heating and cooling curves today. So we'll do it in tomorrow's class and then start unit 7. If you want videos of unit 7, that I can arrange for you from other class because I have already done this unit in other classes. If you're interested, I can do that. So I'm just going to discuss the question and leave it on you. You can see the question in the book also. 68 number. Let's discuss. Yes, Siri, I'll try. Okay. I cannot give you because it's very difficult to upload them. So I can see that how I can arrange it so that you can watch them. There is a YouTube channel. You know my YouTube channel, Siri? Okay, then you do the subscription of my YouTube channel. Those who are interested in watching the videos, like you have Asita, I think she was also saying something like that. Those who are interested in watching videos with the other class, they can subscribe my YouTube channel and then I can give you the link of one of the playlists that is AP Chemistry Group 2, I think. So you can watch the videos. Otherwise, continue with me the way it is going. No, Shrihan, the videos are available of this class only. Means whatever you are learning. But some students have in the school some exam going on, so they are in panic. Okay. So before we end the class, children, can I take few minutes? Combustion, benzoic acid. You are doing burning of benzoic acid. Increases the temperature by this. Calculate the heat capacity. So I will use this equation Q of the water C times delta T. Delta T is given. It's given 2.54. But Q water is not given. So, but delta H of the reaction is given. See here, combustion is this. Kilojoules per gram. So don't worry about the formula. Can you see the unit here? So I can calculate delta H of the reaction as the value is given. So I'll minus Q of the water. This time it is in grams. So I'll divide it by mass. I'll use this equation this time. And once I have Q of the water, which is minus mass is given 0.1584. Delta H reaction, you have Q of the water. Then you can plug in this Q of the water here and get C. C is Q of the water divided by delta T. I calculated Q of the water by using this equation. I know delta T is given in the question. I know C. So this part will give you C. This is the value. Then I can use this C for the rest part. For the rest part, the mass is given, the delta T is given, C you know, so you can calculate Q of the water, C delta T. But this is surroundings, so you can calculate delta H of the reaction, which is minus Q of the water divided by, check the unit, not per gram, not per mole, per gram. So take mass. Mass is given, see? And they are asking per mole also. So in that case, you will change the equation and you convert this mass into moles. That's how you are going to work this question. Is it okay? So I'll see you tomorrow and we'll do the heating and cooling curves. See you. Bye. Saranya, you have a question?